4, grade 9 academic course, Communicating with Algebra. You can, by the way, I noticed these all have this. The textbook references is valid. This assignment questions, you have it on your sheet. You don't need to worry about this. You can see Charlie still intrigued by the lessons, for sure. So 2 things we're going to look at today. We have sort of 2 separate goals. The first one is to just learn some terminology around algebra. And the second is to take a big bunch of information and make an expression, make a math equation or math expression out of it. So take words and turn them into algebra, which personally I'm much happier with words than I am algebra. So I love this. So here we go. So the first part again is just terminology and making sure you and I speak the same language. Okay. Maybe I should say right away, when it's algebra, what is that, right? Algebra is usually, I think of algebra as working with letters and numbers. That's how I think of it. If you look it up in the dictionary or ask a mathematician, it might be something way more drawn out than that. But if you ask me what algebra is, it's being good at dealing with letters and numbers. And you say, why would I care? And it's amazing how powerful it is. That's the amazing thing. Something as mundane as that. And as a physics person, I could go on forever about, what, Sir Isaac Newton or Albert Einstein were being able to figure out. And all Albert Einstein ever did, and Newton for that matter as well, was work with letters and numbers, and more letters than numbers. And they figured out the laws of nature that govern our universe, right? It's just algebra. Well, it's way more than algebra, but I mean, that's what it looks like. And so that's why I care. And you might have your own reasons. Anyway, so what I say term, what do I mean? First of all, if this is some sort of algebraic expression, it's some sort of algebra, okay? And the word term means one part of it, and everything's separated by positive, like plus and minuses, right? Which is really kind of like a positive and negative, same thing, really. A term is one piece of it, and so 3x squared is one term. It's a combination of numbers and variables. And I probably should have said it here, but why don't you write this down as I say it? And now I know if you're listening. It should also include the sign in front of. So a sign, a positive or negative sign, numbers and variables. So because this, I think this is the best example, this term is not 5. This term is minus 5. The whole thing. I don't think I did a good enough job in the picture making that clear, but I'm trying to in my words, and I hope you make that clear in your notes so you remember. So let's move on to something called a polynomial. This whole piece is a polynomial. It's algebra, letters and numbers, and it means you have more than one term that is subtracted and added together. Okay? Okay, degree of a term. Degree, it mostly means the exponent. That's the easy way of looking at it. So the degree of this term is the exponent on the variable. It has to be on the variable. If I had 3 squared times x squared or something like that, it wouldn't be this 3 squared. Or if I said 3 cubed or something, it wouldn't be the cubed, because 3 cubed is really just a number, right? But x squared tells me the degree of that term. So remember that if it has no exponent, that means that it's x to the exponent 1. It's implied that that degree is 1. And lastly, you could have a term that has like more than just one letter. It doesn't have to be just one letter, and they can have their own exponents. So this degree is the sum, and then when I said sum, right, that means add. So I'm adding up 4 and 2. Okay, as I skip ahead, reminder that you don't have to go with me. You can pause and join later. Okay, if you're looking at a full polynomial, and you'll just see questions like this in your review, or sorry, in your assignment question, but what is the degree of this polynomial? And it's just look at the highest, basically it's the highest exponent you see. That'd be the easiest way to say it. It's the degree of the highest degree term, but when I look at it, what I'm looking at and thinking to myself is it's the highest exponent I see on a variable, on a letter. Term monomial, it means I've got some combination of letters and numbers, but there's only one term. A binomial, 2 terms, and a trinomial, 3 terms. Okay? Again, pause if you need to, but I'm going to skip ahead. Coefficient, it's just the number and I said before, it doesn't have to be before. It could theoretically, it could be x squared 5. Though you never, like, it makes me feel queasy even saying it. You never see it that way, though theoretically it's just as correct. Okay? But it's the letter. It's the number, right? It's the number that goes with the letter. Not the exponent, mind you. It's the number that's multiplied. And then just finally, if you have a polynomial that has more than 3 terms, because we said there's monomial, binomial, trinomial, anything more than that, you just say 4-term polynomial, 5-term polynomial, and that's what Pn is, polynomial. And lastly, from a communication point of view, as often as possible, write the polynomial in order of highest degree to lowest. Basically, you write the highest exponent term first and the lowest exponent term last. It's mathematically correct to say that this expression is the exact same as -5 plus 4x plus 2x squared plus 5x cubed, but you would never do that. You would write it this way with the highest exponent first. It's just how we do it. Okay. On to, and there's Charlie in the grass at the soccer field. On to a very fun term called algebraic modeling. And all that means is make a word sentence turn into a math sentence, right? And this, I'm very happy with that because I'm not a language person by any means. I don't have the best grammar in the world. But not to belittle the importance of that, but my strength is in math and I'm more comfortable with math. So I'm happy to do that. I would like you to, in fact, I'm going to do this right now. I'm going to put a big box over my example here, so I don't want you to look at it right now, okay? I'm going to cover it up and I don't want you to look at it. Feel it. There we go. Okay, let's look over here. This here on the right, when I say the word grass, what that means is not Charlie's comfort little zone, play zone there. We use grass. That's just an acronym, which means just a term that we use in math at Northwestern. And I think it gets used all over in some form or another. I use it in physics class. I think it's so important in physics class. I think other physics teachers do. I've heard them use grasp before. Whatever, it doesn't matter. What it is a strategy for dealing with a word problem specifically. That's when I use it in an actual situation where you lay out your strategy, and every problem is solved following the same strategy. And it's good communication, which is nice. It makes it easier to read and follow. It demonstrates you know all the steps. But the reason I do it in physics, especially when you get this really hard stuff we do in grade 12 physics, and that is a kid might have no clue how to get started on solving a problem, but sort of you just, I don't know, just look at it and list the givens. Like if you say, I have no clue where to start, but if you even just start here, and I'll say, well, you get some communication marks if you do these steps. Then if you kind of get through the first couple, then you start to, it sort of lays it out. It helps you be a better problem solver. It's not just about communication and making Miss Stone happy because your problems look nice, because aesthetics aren't really my thing, but good problem solving is. Okay, so that's what grass is, and I use it, we're just going to use it throughout the year. You're just going to see it lots and lots of times. So let's look at this example where we have Ferd, and Ferd's someone you're going to get to know over the years. You'll see him here at Northwestern. He's all over, really. He's selling band t-shirts. And he's selling Beebs t-shirts for $5 each, 1D, One Direction for $10 each, and my favorite band, Pearl Jam, for $30 each. Pearl Jams they're old like me, and pretty much when you get to our age, you can afford to pay $30 for a band t-shirt. Anyway, so the first part of the question just says determine a variable for each t-shirt type. So it just means, well, what I did. Let J be the number t-shirts sold. So I'm picking, this is where you usually use a let statement. You make it nice and formal. Let J be. Yeah, you let D be, let P be. And it's a nice way, formal way of introducing your problem and saying that, okay. And the other thing is that, you usually you pick something that fits, right? So I'm not going to use X, Y, and Z or A, B, and C because it doesn't fit. But J it's natural. That'd be the J Beebs, and D would be the One Direction, and P for Pearl Jam. Okay? And then it says write an expression for the amount of money Ferd will earn based on the number of each type of t-shirt he sells. Okay, well, how much will he earn? Well, he'll earn $5 for each J. Beebs t-shirt. So 5J. 5's the coefficient, J is the variable, plus 10 times the number of Direction 1D t-shirts, plus $30 for every Pearl Jam t-shirt he'll sell. That's what that question's asking us to do, right? Expression for the amount he'll earn, right? And because of what we're told at the beginning, right? Part C says, well, if that's how many J. Beebs, and that's how many 1D, and that's how many Pearl Jams, how much will he make? And this is where I'm going to apply the graphs. So when I'm actually solving a question, graphs fits quite nicely. Okay? So first I'm going to list, okay, well, he sold 20 J. Beebs t-shirts. He sold 6 1D t-shirts and 40 Pearl Jam t-shirts. Okay? So that's my givens. That's what the question tells me. What am I looking for? I'm looking for his earnings. What's the formula that I'm going to use? The formula is the expression I came up with. So then and then S is sort of sub in and solve. So I'm going to sub in, instead of writing J, I'm going to write 20. Instead of writing D, I'm going to write 6. Instead of writing P, I'm going to write 40. And then put that in my calculator, or if you want to impress me, do your math in your head. And if you think about it just quickly, let's think about this without our calculator. 5 times 20 is 100. 10 times 6 is 60, so I've got 160. 30 times 40 sounds hard, but 3 times 4 is 12. Add 2 zeros, one here and one here, so that's 1200. So 1200 plus 160 is 1360. So you could do that in your head. Anyway, so how much will he earn? My state the solution, therefore Ferd will earn 1360. Okay? One more question. Okay, now Ferd also makes money by having 3 different part-time jobs. This is really the same question, by the way, that we just did. He delivers pizza for Pino's, earning $11 an hour. He works as a go-go dancer, earning $17 an hour, and he catches chickens for $21 an hour. And same thing. A, find a variable for each job. B, write an expression, right? And C, sub in based on how many hours he does for each. Okay. So in A, we're going to say P for Pino's, G for go-go dancing, and C for catching chickens. That's what I chose. If you chose something different, that wouldn't be wrong. I am looking for something that makes sense, right? Write the expression. So he earns $11 for every hour at Pino's, right? So 11P. He earns $17 as a go-go dancer, so 17 times G. And he earns $21 for every hour he catches chickens. Okay, so now when I do the graph statement, you say, okay, C, and if you look at the question, it says he works 4 hours catching chickens, so that's C. He works 8.5 as a go-go dancer, and he does 14 hours at the pizza place. So now, again, we're looking for his earnings, how much he earns, and you take your A as apply the formula. S is substitute and solve, so instead of P, I write 14. Instead of G, I write 8.5. Instead of C, I write 4. Right? Just subbing in these numbers, and you do that one. I'll give you that. You probably do that in your calculator just because the decimal, and you get 382.5. So that's Ferd's earning, 382.5. So that's the end of this lesson. Please ask if you have any questions or write it down and ask me in class.